Thanks.
Thanks everybody for attending. For those of you who don't know who I am, my name's Wayne Stambaugh. I'm the lead developer for the KiCad project. I'm going to talk. You got it? All right. It's that directional? Okay. So yeah, I'm going to have a, okay. I'm going to talk today about the current state of KiCad and the state of KiCad going forward in the future. It's a pretty big presentation. I'm going to try to power through it as quickly as I can. You can download it. It's been uploaded to the Teardown website. There's some nice video clips in there of how to use some of the new features. I'm not going to be able to have time to let them play out, but you can download it and look at them on your own time when you get a chance. So without further ado, talking about some project news. Unless you didn't know, the stable version 8 of KiCad was released on January 31st of this year, and that's our usual annual release cycle. We always try to release on the 31st of each year the next new version. So financially, the KiCad project is in great shape. So we earned over $200,000 last year, and at the end of the year-end campaign, the beginning of this year, we had the donation campaign for version 9. We've raised over $100,000. Last year, we had the first KiCon Europe in A Coruña, Spain. That was on September 9th and 10th of 2023. We also had KiCon Asia. So KiCad has a quite large presence in the United States and Europe, but we're really growing in Asia. In fact, if things keep going the way they are, probably by the end of the year, China will be the biggest KiCad user worldwide. One of our sponsors hosted the first KiCad conference in Shenzhen, so it was very, very good, well done. We added 3 new members to the lead developers team. That's probably the single biggest number we've ever had in a single year. Wachu Next PCB is providing 2 paid full-time developers. Now, full-time is a bit of a misnomer. They also work on the Wachu stuff for the Chinese market of KiCad, but they also contribute. So there's quite a number of new features that they've contributed to KiCad. One of the big places where we improved is we had a huge backlog in our library merge request system. Last year, we got a new head librarian, and they put together a really nice new team. The backlog's really been knocked down to just a handful. They've really done a good job. And we now, for the first time in KiCad, we have a dedicated tech writer. So the KiCad documentation they've cleaned that up quite a bit. It's really nice now. One of the things that's interesting is, related to libraries, is Worth Electronic has, I had met one of their management team, and they decided that they want to contribute. The goal is to contribute their entire product line of symbols, footprints, and 3D models. Currently, they've got, I want to say they have most of their inductor, like their wound inductor line. I think it's all done. But that's significant because in order to be part of the KiCad library, to have a symbol or a footprint or a 3D model in the KiCad library, you have to use the KiCad Creative Commons licensing. So for a corporate entity like Worth Electronic to step up to the plate and say, yeah, we're going to do that, it's a big deal. So, and I expect over time, the goal is they want to do their entire product line. I'm sure that'll take a few years. They're quite a big company, but they've done a great job so far. As I mentioned earlier, there's a significant increase in Asia. We now have 6 platinum sponsors, which for those of you who don't know, that's $15,000 a year annually. And 2 years ago, we had 0 platinum sponsors. So we've really come a long way in the last couple of years. We have 5 silver, 6 bronze. There's the possibility of 3 KiCad conferences annually. We didn't get one in the States this year because we just didn't have the manpower to run one. But we are going to have 2 this year, one in Europe and Asia again. So the one in Europe is in September. If you go out to the desk where I am, there's a brochure. You can click the the QR code, and that has the event information and the tickets in Bochum, Germany. Oh, I copied the wrong one over. That's the 18th and the 19th of September. It should be question marks. And the KiCad store is now open. Some of the merchandise I have with me that I'm selling today is available on the store. And we'll be adding more merchandise as time goes on. Right now it's pretty limited. not because we want it to be that limited. It's just finding the time to add new products. So I always like to give a nod to our platinum sponsors because it's a big deal. They provide the revenue for us to pay developers to work on KiCad. KiCad's a non-trivial project. If you've ever looked at the source code, you'll know that. Eisler, DAI, our friends at DigiKey, WatchU Next PCB, KiCad Services Corporation, which I'm personally affiliated with, and PCBWay. Those are our platinum sponsors. So version 8, here's what happened during version 8. If you haven't used it yet, or you're not completely familiar with it yet, there's been a lot of improvements, significant improvements over 7. We made some huge changes to the SVG exporters, so you get better exports of your VGAs. There's now a splash screen, which some of our rebranding people asked for. You can do, I knew this was going to happen. It worked perfectly on Linux, but now I'm on Windows and now it's not happy. So maybe this is not going to work as well as I thought it did. So we now have alternate hotkeys. We now have ARM binaries. So if you have an ARM Windows machine, we have ARM binaries for ARM. We've always had them since the M1 has been out on Mac, but now we have them for Windows ARM builds. We have a lot of people. It's frustrating. So EasyEDA, we now have an importer. So if you use EasyEDA or EasyEDA Pro, we can import with pretty good fidelity those projects. So it's pretty easy to convert them to KiCad. You can now run ERC and DRC from the command line. So if you want to automate any tooling, like say somebody makes a change to a board or a schematic, you can run the ERC and automatically flag ERC errors with scripting, like through a CI, some kind of CI runner. You can do that now with KiCad. You couldn't do that before. There's Git integration. So Git's now integrated directly into KiCad, so you can do your Git integration, your version control right from KiCad. You don't need to shell out to a Git tool separate from KiCad. It's built right in. So the property panels, one of the big UI changes we made was now all of the editors. The schematic editor, it was in the board editor in 7, but now it's in the schematic editor, the symbol editor, and the footprint editor. So the properties panel, click on an object, change its properties over here without opening the dialog. You can click on multiple projects and change the common properties at the same time, like one big go. It's pretty handy. We have a highlighted net navigator panel. So what happens is if you highlight a net in KiCad, it turns magenta, and then you can kind of see how that net traces out. One of the problems is if you have deeply nested hierarchies, which we do for a couple of our, a company that does some real complicated stuff for us, or in KiCad, makes it really hard to trace that. You don't want to click a sheet, and keep following the pink line, right? So there's now a panel on the left-hand side that you can just go click on the object, takes you right to the sheet in that object. There's now a search panel so in the past we just had a find dialog. Now there's a comprehensive search panel, so it sorts things by objects, makes it easier to do complex searching. We have an integrated bill of materials tool now. You no longer have to use external scripting to generate bombs. It's just set it up, CSV file or whatever file format you want. There's a grid alignment tool. So for those of you who are familiar with KiCad's schematic editor, one of the limitations is things tend to have to be on 50 mil grid, which is fine when you're doing the symbols and whatnot. But if you're drawing other things like lines and arcs, graphical stuff, you don't always want to be on that course of a grid. So there's now a tool that automatically, depending on whatever you're drawing, will switch the grid back and forth automatically for you, so you don't have to do that manually anymore. And then keep track of what grid you're on. Symbols now, you can nest right in 7, you only have a single level inheritance for inherited symbols. Now you can nest that as deep as you want. So makes making atomic symbol libraries a lot easier. So you can have like one main symbol, maybe the 0603 variant of like a resistor, and then like all the individual part numbers that make up all the, so you don't have to keep reusing the same pieces over and over again. You just use one, and just go up the inheritance list. There's now a tool to check for symbol library differences. So, you edit starting with 7, the symbols were embedded in the schematic files, right? So if you changed it in your library, it didn't automatically get updated like it used to in KiCad. So now there's a tool that allows you to, hey, did it change in the library? If it did, it'll pull it in. We now have CADStar, Altium, and Eagle symbol library importers. So you can just, if you have any of those libraries laying around, you want to reuse them, it'll bring them in as accurately as it can. As long as there's a feature in KiCad, it brings it in one-to-one. So now you don't have to convert them or use some third-party tool. You just suck them in. You just add them to your library table like you would a KiCad library and just use them as is. There's now a hover. So like if you're in the symbol editor and you hover over a part, it'll give you a little snapshot. It'll pop up. It'll show you so you don't have to double click on it and see it in the editor. It's just you can just kind of like browse up and down. It's kind of handy. We added a file change watcher. So if you're editing like a symbol or a footprint in another tool and you have it up in the editor, it'll automatically detect it and reload it in the viewer. And if you try to make a change, it'll say, hey, that's been changed on the disk. You sure you want to overwrite the other changes? So it's a handy tool if you're using multiple tools to generate, because we do a lot of in KiCad, we do a lot of scripting to generate symbols and footprints. We don't do a lot. A lot of that stuff isn't done by hand. It's done by a complex parametric script. It makes our life easier. So that was added for that. So you can now migrate third-party tools with one shot. If you look down there in the right-hand corner, there's Migrate Library. So let's say you have a bunch of third-party libraries. You got some Altium libraries, some Eagle libraries, whatever. You just want to convert them to KiCad because obviously we can't edit those libraries using KiCad because we don't write to those file formats. But if you just want to do a bulk save to all your third-party libraries and then you want to go in and edit them and change them for KiCad, it's just one button, reloads them. Now you have them all in KiCad. We've added differential cursors to the simulator. The simulator got a lot of changes for version 8. It's really pretty impressive. This is just a very cursory overview of what we added. We can now import, unfortunately, we can import LT Splice schematics. So if you have LT Splice designs, just suck them into KiCad just like any other third-party schematic, and then you can simulate them. And then we also added FFT. Here's a really lousy oscillator that I made just to show the output of the Obviously, you want to have one nice spike there in the middle, and the rest of that should be smooth all the way down. I just made that for show and tell. And now we support S parameters, Fourier. So we're not LT Splice yet, but our Splice simulator has gotten really, really good, and then there's a bunch of improvements coming up in 9. Just a lot of just massaging of the simulator so that you can use KiCad, you can simulate in KiCad as is without having to redo your schematics in LT Splice and then use that to simulate. You can now import SVGs and DXFs into the schematic. That used to be you've always been able to do that in the board editor. You can never do it in the now you can in the schematic editor. And if you still use Cadence Allegro as your PCB designer, you can export their netlist now. We now support direct to that. So that's the schematic editor. The board editor. We also added a check tool for that checks, runs during DRC. It'll check and see if there's a difference between the footprint in your library, the footprint on your board. If it is, it'll say, hey, do you want to change it? Give you that option. There's also, like in the symbol editor, there's now a footprint. You can import Altium footprint libraries directly. They'll just look like the Altium library, and then you can do the same exercise that you could with the symbols. You can save them immediately, batch save them to KiCad files if you'd like. We now import SolidWorks PCB files. That's just a rebranded Altium, so it wasn't a very difficult. It wasn't a difficult load for us, so we had that. We've added do not populate flag for your position file. So one of the things that it doesn't quite do a perfect job of back and forth between the schematic because there's some issues with the different flags there. But you can now, like, if you don't want to import for your pick and place machines, if there's like you got a test point or something like that, obviously you don't want to export the position of that footprint. So you can do that now. We now allow you to add connectivity, so you can draw any random graphic shape. Prior to this, you couldn't assign it a net. It had to be part of a footprint to be able to assign it a net. Now you can draw any random copper shape, go in and assign it a net, and then attach a trace to it. It's helpful for RF guys, people doing things like guard rings and stuff like that. It's not quite a replacement for a guard ring generator, but makes it nice to be able to, you can make nice fancy rings around your high impedance circuits and sign in a net and away you go. We now have an interactive meander tuner. We've made some really significant improvements in that in 8, and we're making some even more improvements in 9. Talk a little bit about that. So that was a big dialogue now that allows you to do that. We've done some significant improvements in our step dialogue output. You can even, if you really want to have huge step files that nobody will ever use, you can import all your copper features onto the end of the step. And the reason we did that is at some point in the future, we know we want to generate the 3D meshes for EM simulation, so we have to be able to export the copper as is. But you can do that now in your step files if you care. It's available. We had property. Obviously, the property panels went into the footprint editor. Also, one thing I didn't point out was you look in the lower right-hand corner. There's the selection filter tool. So that allows you can select those different objects, and when you go to do selection, if they're turned off, you can't select them, right? That's all the editors have that now as well, including the schematic and symbol editor. So if you just want to select symbols and ignore all your wires and your labels, you can do that, which is real handy when you're for complex designs. We now support IPC 2581 export. That was added late in the dev cycle. It's met with mixed reviews. I don't know that 2581 is really highly supported by the manufacturing industry just yet, but when it is, we have it available. And there's just a picture of the dialogue. So there's big changes to the 3D viewer. If you look on the right-hand side, there's a whole, you can create custom viewports, change the colors of the layers, all that stuff. There's like a layer tool on the right-hand side. That's available. So here's a table of third-party tools that we support importing. So if you look, the blue was KiCad 7. The oranges are all the things we added in KiCad 8. And we've got really good coverage. There's only a handful of places that we don't. Gita, we don't support real well. There's the few project level things in Altium that we don't import completely. Some of it's because like our custom design rules don't necessarily map directly to Altium's design rules. So there is some fidelity loss there, but the schematic and the board imports are pretty good. So I always like this is something new I started doing. It was just some fun facts of, about the project. So for version 8, there was 4,500 unique commits by 15 different authors. To put that into perspective, I think there was 2 days during the entire V8 dev cycle that didn't have any, there was no commits to the repo. So 363 days a year, there was one or more commits. So KiCad's an active project. We're just constantly moving. Currently, KiCad is 1.63 million lines of code, C++ code. not including translations. That's its own whole entity, of which 160 or 176K are comment lines. We had 358 commits to the symbol library. We added 1,077. We have 20,023, 233 symbol libraries. Same with the footprint libraries. We have 1,335. We have 6,465 3D model libraries. So our library infrastructure is growing. It's doing really well. And the quality of our libraries is really good. We have a library convention that we make people follow when contributing footprints and symbols and models, and the consistency of our library is good. I'd put our libraries up against any of the commercial ones available. We make it a point to follow the IPC standards, whether you love them or hate them. That's a personal thing, but we do follow standards, and so one symbol looks like every symbol, one footprint looks like, we use the same silkscreen monikers, same line thickness and all that stuff. So translations, so we kind of went backwards in V8. We have nine languages that were 99% plus translated. Now we did have 17 for V7. I don't know what happened there, but most of them are 95% or above. So we are translated in over 17 languages. Here's some interesting. People ask me how popular KiCad is. I know this is a small snapshot, but this seems to be true of all the board vendors that we interface directly with. Eisler's monthly usage stats for December 31st had KiCad at 42% of all orders. I know for a fact that number's over 50% now. Osh Park, their 2023 usage was 37%. We see similar numbers from some of our the Chinese vendors that we work with. So I think it's pretty safe to say that KiCad's probably the most popular EDA tool in use right now. Now, I know that's not the sample of every board manufacturer in the world, but like Next PCB and PCBWay are pretty big board manufacturers, and so if we're up there in their lists, it's probably a safe bet that we're up there in a lot of them. Okay, so version 9, here's what's coming. There won't be as many pictures here because a lot of this stuff's still in work. Internal procedure call. One of the things we're going to do is we're going to clean up our scripting libraries. Scripting libraries are currently just wrappers, which it's great because it makes it easy to create Python scripts. Bad thing, it lets you, any rogue script, take down a running KiCad instance, so that's bad. So we're gonna put a layer in between that in the future. So if you're a script writer, don't panic. We're not getting rid of the scripting stuff just yet. That's a couple years down the road, but we're putting the infrastructure in place now, and in fact, it's actually been committed to the development branch to make KiCad a little bit more stable. So if in case you try to do something rogue with a Python script or any other scripting language, it'll trust me, you'll be glad in the long run we did it that way. We hope to get some customization of the user interface layouts, including toolbars. This is kind of in a gray area with us because WX widgets, even though it supports that, it's not as stable as I'd like it to be. So we may have to wait another version or two of WX widgets before we turn that on, because I want the experience to be good. So that's one of those ones that may or may not make it. We are working on a visual diff tool. So for our Git integration, right now the Git integration is just basically yours, theirs, mine, theirs, or manually merge, which in a text-based editor is not the most pleasant thing to do. But we are going to have a graphical merge tool in version 9. Embedded licenses. In fact, we've just added a general embedded file format. So going forward, 3D models you can embed your 3D models in the board file if you want to, instead of having links to an external file. It's kind of nice because they're portable. It's kind of not nice because it makes your board files massive. You have a couple of complicated 3D models, and now your board files get rather large. But you'll be able to do that in KiCad 9. People have requested barcode support for a long time. We also are going to have a PADS project importer and a Gita project importer, and that should pretty much cover almost all the major EDA tools. So we'll have importers so you can, maintain your legacy designs. If you have, I'm not naive. I know everybody's got thousands of designs in every EDA tool known to man. So we try to import them with the best fidelity that we possibly can, so that you can migrate easily to KiCad if that's something you're interested in. You can add comments now. So like the DRC tool, like say you have a comment, you got a DRC warning, but you say, I ignore that, and here's why I want to ignore that. So you can tell another developer, this is why you ignored this DRC warning. You can do that in DRCs and ERCs as well. Here's an interesting, somebody just added this out of the blue. You can now do fancy 3D ray traced rendering from the command line. So you don't need, you can just set it, here's the command line above you can see here, and this is what it rendered. This is the standard KiCad video example. So you can make fancy, like, rotated render. You could stitch a bunch of these together and do an animation. Who knows? I mean, I don't know why you would use it, but it's there. We have native table support, so you can draw tables just like you would in any other application now, in both the schematic editor and the board editor. So one of the nice things that the command line, so right now you can generate all your, for those who are familiar, you can generate all your outputs by the command line interface, right? So if you want to do, like I mentioned earlier, like CI scripting jobs, where you're constantly somebody checks in something, you run the DRC or the ERC on it, you flag any errors, whatever. Well, one thing that we like to do is we want to do an output job manager. So right now you can generate Gerbers, SVGs, PDFs, whatever, all your documentation files from the command line. But we're going to create a tool that allows you to manage that all in one go. So you'll be able to define a set of outputs that you want for your project, click a button, you'll get all your outputs. That's been a tool that's been requested for a long time. Schematic editor, there's already a synchronization tool for the hierarchical sheets and pins. So, you add a bunch of pins to your sheet. They don't show up when you go into the schematic, they're not there. Well, there's now a tool that syncs back and forth between the two. It's really, really handy features. It's really cool. I played around with it a little bit. Our friends from Watchu and did that one. Rule areas. Right now, you can only assign a rule to a single net, right? Now we have a new tool coming out in 9. You can group a bunch of nets and assign it the same rule. So, like, say you have in this case, it's a bus. If it's a high-speed bus, maybe you have some, you want to do, meanders or whatever. You have a length, and you want to meander that set of. So you can just, instead of having to do each one individually, one at a time, you just grab the set that you want to change, and away you go. This one's probably going to be a little controversial. One of the things that we've done in the past, and it was probably a design mistake that preceded my involvement in the project, is we always allowed schematics to be shared. And what happens is, every time you reuse a schematic and like leave it where it is and reuse it in another project, if you notice, all the instance data for the other projects end up in that file, right? And what happens, you end up with orphaned instances when you quit using it. And so you got all this extra crap in your symbol definitions that cause a whole bunch of problems for us, like some of the copy and paste errors that we've had over the years where it doesn't quite work right is because of that. We're going to do away with that in 9, and we're going to go with a more traditional shared approach where if you change it on one schematic, when you open up your other schematic, it's going to have the changes in it. What we're going to do to mitigate that is we're going to have variants. So these two things come together. So when variants are implemented, you'll be doing the reference designators and the units at the project level, not down at the shared board level. So it's going to be a slight change. There'll probably be, I'm sure there's going to be some growing pains there when we do that, but that's coming. There's a design blocks. I think initially it's just going to be slated for schematics. You'll be able to define a circuit. It'll be in a library, like Symbol or any other KiCad entity, and you'll just be able to plop it down. You can include simulation stuff with it. It's shaping up pretty nice. That hasn't been committed yet, but I've looked at the branch that's being worked on, and it's looking pretty good. As I mentioned earlier, we're going to have variants, so now you can have, most of you who've done same as except type designs know what variants are. You have one design and you have like 3 different say you populate you use 3 different parts for the same symbol. You know, maybe you have a high-speed op amp, a low-speed op amp, or you have maybe it's an RC filter, and you have, for one design, you have this filter. You don't change the circuit, you just change the R's and the C's. So that's what variants are. So you'll be able to define as many variants of a single schematic as you want, and then you'll be able to print bombs out for each of those variants. There's a table editing tool. So you're familiar with our current table editor. We'd like to expand that. You know, the symbol, the field editor, we want to expand that to include maybe all the parameters of an object, to just be able to edit them in one big table. We have a Bezier curve tool coming. We support Beziers internally. In other words, we export them or import them from other tools. We just don't have a drawing tool for it yet, so we got to get on that. The Net Navigator, which I mentioned earlier, we've expanded that to include all the nets. We had to do some serious performance work before we did that, because the reason the current version only supports the currently highlighted net is because on really complex designs, this tree gets massive. So we had to do some of that, but that's shaping up nice. So you'll have a panel, if you can dock it, and you can look at every net, just click on the objects in the net rather than manually go through your schematic. So board editor features. This is the new zone manager tool. Right now, zones are managed one at a time. You click on this zone on this layer, this zone on this layer, this zone on this layer. Now you can manage all your zones in a single dialog. Make all the changes, click OK, they all get updated, refilled. Multi-channel designs, we also have somebody working on like duplicate layouts. So let's say you have a signal conditioner for an A to D input, you know, multi-channel A to D input. You design the first one, you just copy it. It maps up to the schematic. As long as they're in the schematic, it'll map up. So you have identical layouts for each channel. Pad stacks, this is important for us because a lot of EDA tools have pad stacks. So right now when we import them, they're all converted to circular pad. The annular rings are all circular because that's all we support right now. Pad stacks allows you to define any shape on any layer that you want. And so having pad stacks will allow us to be able to import accurately from third-party tools. Guard rings, I don't know if this one's going to happen, but we'd like to have the routing tool handle guard rings. Right now, you can't draw a loop. It won't do it very nicely. We want to integrate. We've been talking about this for a while too. Being able to have like a grid overlay for laying things out, like a polar grid, or like a special offset grid off from the normal grid for you to just lay out footprints on like a custom grid. Also, Bezier curve tool would be in the board editor, table editing tool. I mentioned earlier about the embedded models, 3D models. That's already done. ODB plus export. This was one that's been requested quite a bit because a lot of modern tooling uses ODB++. I know that our friends at Watch You Next PCB already have a working branch of this because all their tooling is ODB++. So the nice thing about them working on that is I could write an ODB++ exporter, but I have no tooling to verify it on, which means I'd be chasing my tail. So I think once that's done, our ODB++ export will be pretty good. So that should go in 9. I know they're pretty much done with it. They're just testing it now, just running it across their system. We have a dockable net inspector. That's already in. You can look at all the nets and a board. It's on the bottom. We just introduced via tenting. So in the past, all you could do is tent on the whole board, both sides, right? Now you can tent per via tent top only, bottom only. That's available in 9. Oh, what happened? 3D export. Okay, so one of the things that we're working on is we've added extra output types of our 3D models, including BREP and OXA. And what that does is that gives us a migration path to, it's hard to tell here, but those are mesh. Those are mesh models of a piece of the copper on your board. Mesh models will get us to EM simulation. We need to be able to mesh output to run it through. Right now, EM's. I did have it in here. The last entry was EM simulation, but I think that's going to be a bridge too far for version 9. We're still trying to get some. We're trying to find a 3D or an emulator model, an EM, and some of the was it Sparse Lizard? They don't build on every platform, so we were trying to work with some of the upstream people to get us to the point where we can have our own EM simulator like we have our own Spice simulator, rather than having to export the 3D models and then import it and then do the simulation through a third-party tool. We'd like to at some point have that integrated into KiCad, but I don't think that's going to make it into 9. But at least we have the infrastructure in place, so when we get there, and somebody contributed a tolerance calculator for your regulator, so you can put in the tolerances and get the range of actual voltages that you might get out of your regulators. So that's pretty much it for 9. That's probably not completely inclusive because somebody always steps up and does something unexpected, and I never see it coming. So there may be other things that make it in. You can go to the KiCad forum, user forum. There's a section that's called Post V8 Development. And basically, as the developers add new features or make changes that are user-facing, they'll put a blurb in there so you can kind of track what's going on. If it's something you're interested in, you can track the development of KiCad without watching every commit go in every day into the source repo, which is probably a little not what you want to do. Trust me, it's a lot, because that's what I do every day. So I just like to take this time to say thanks. I really want to thank all the developers who contribute their time and talent to KiCad. I get to stand up here as the project leader and be the face of KiCad, but I'm just one small part of that, of a much bigger ecosystem. And those guys deserve the nod. Guys and gals deserve the nod for all the hard work they do. It's fantastic. Thanks to our sponsors. KiCad is in a unique place amongst open source projects where we can now pay developers, which is, helps sustain the project. I mean, you can't expect people to do the kind of work, because KiCad's non-trivial work. The geometry stuff, the 3D modeling stuff, it's complex. It's not easy code. So to be able to, throw people a bone and keep them interested in working on the project, I thank everyone who's donated, both corporate donors and personal donors. Thank you very much. Thank you for being KiCad users. KiCad's a community. It's not just a community of developers. We depend on our user community. It's like the old, if a tree falls in the forest, is making noise. Well, if nobody's there to hear it, maybe not. If I write a great piece of software and nobody uses it, so what? So the users are important, and that's what drives KiCad. And we will continue to support our users in every way we can. We know you have designs that you want to work on, and that's our goal, is to make your life easier as engineers and designers, is to give you the tool that you need to do what it is you want to do. Special thanks to Helen. I was not even aware of Teardown until she contacted me and asked me if I would give a talk. And I was like, well, thank you for asking. I'm flattered. So yes, thanks to Helen for inviting me, and I appreciate it. And hopefully, if you can make one of the KiCon conferences, I am going to do my absolute best to get somebody on the ground in the United States for 2025, so we can have a KiCon in the United States again, because the first one was in Chicago. It was such a tremendous success. There's a few people here that were at that one. Ask them. They'll tell you. It was just a fantastic conference. I'm hoping we can have another one. If that being said, I will throw it out there. If you know somebody who's really good at that kind of organization stuff, because I don't have the bandwidth to do that, and I don't think anybody on the development team does. But I'd be happy to coordinate with somebody and let you take that ball and run with it. Have them get in touch with me, because somebody has to be on the ground at the site where we're going to have it. I don't see how you can possibly organize a conference unless you're there, because there's so much, caterers, getting the building. If you were here Thursday when they were setting up, it was just like a little bit of madhouse kind of thing going on with everybody trying to get everything set up. That kind of stuff I can't do from a remote location. So if you're interested, or you know anybody you thinks might be interested, please get in contact with me. I'd appreciate it. So I probably went over my time, didn't I? Well, we got a few minutes yet. If anybody have any questions? I'm always happy to answer questions. Yeah.
It's basically about the variance. I'm really curious about the variance stuff.
Okay.
Where will it live? What can we change? The symbols are properties and attributes and a whole bunch of stuff, and then you're going to have this resharing stuff.
Right.
Where will those live?
So the question is, where will variants live? The variants, initially it's just going to be schematic variants, but the variants will live in the schematic. So that way there, when you share, you can share designs, share the individual schematics, but in the current project you're using, you can change the reference designators, what we call now instance data, like so reference designators, units, and then for sheets, it's page numbers. All that stuff will migrate up to the project file. So none of that stuff will get stored for every project in the schematic file. So your schematic files will be much cleaner. It really cleans up the schematic files. So variants will live at the highest level, which is at the project level. So that stuff will all get saved in the project file. But the nice thing is you'll be able to define as many variants for a single design as you want. So there's plenty of examples of that. Like I said, an RC filter. Maybe have a 10K RC filter here, 5K for this one, and it's just a matter of changing. So you'll be able to change values. Actually, you'll be able to change any field or property of a symbol as well as like variables, right? So let's say you have a variable. A lot of people use variables now. They're at the sheet level, but they're going to be part of a variant system moving forward. So like maybe for this variant, that variable is X, and for this variant, that variable is Y. And variants will just be named. They'll be the default variant. You can give it a name, or you can leave it default, and then you can just add variants and then change all those. So like when you go into the symbol editor, you'll be able to pick the variant for that symbol and change whatever properties that you're allowed to change for that. Like a field, say maybe instead of a 10K resistor, it's a 5K resistor. Or maybe it's a 1 watt instead of a half watt or a quarter watt or whatever.
Just save the deltas from volt.
Yeah, and then when you want to export a BOM for that variant, you pick that BOM, pick that variant, export the BOM, and it'll have the variant changes in it. It'll just for that variant. So, yeah. Eventually, we hope to expand that to footprints, because there are cases where you might have like maybe have a BGA inside of a bigger package, right? Same chip, you just pin them, you just break them out into the two different footprints, and maybe because of people have done this in the past just because of part availability. You can get the one version sometimes, and you can get the other version sometimes. So you just populate, maybe it's a processor or some kind of complex ASIC or something, but you can pin them out to multiple footprints. So eventually, the variant system will go there, but I think the first iteration will just be schematics. It won't include footprints. So that would be on the board. So you'd have two footprints on the board, and then you'd wire them up. Any other questions? Nope. A 9, yes. Yeah, so. So the question is, what's the visual diff going to look like? So it'll be like, we already kind of have a tool that kind of does that. Have you used 8? There's a diff tool in 8 So like if you have a symbol that's changed between the board, the schematic, and the library that it's in, there's a tool that allows you to, it kind of does a map, and you can change the transparency one way or the other, and you can see what's different. It's going to be something along those lines where it's going to be, you overlay the one, overlay the two changes, the get changes that you're requested, and you're going to say, I want this one, I want that one, or I want something in between, and it'll do the, it'll calculate what the in between is, rather than having to do that. Even though KiCad files are text-based, obviously, and you can do it with a text editor, when you're doing board layouts, it's not you want to be able to do things visually, not text-based, because you have to understand the file format to do it text-based. So yeah, there'll be a viewer, and then you'll be able to say, well, no, I want that. No, I want that, or I want something in between. Maybe I move a trace a little bit and take something somebody else put in there, and then that looks better. And then you commit that to the Git repo. So it's a diff between the two, the deltas between what's currently in the repo and what's being. And I think that tool kind of lays the groundwork for some future work. We've talked in the future about maybe doing multi-user editing. Collaborative editing. So that kind of tool kind of lays the groundwork for that. So like if there's a conflict between two parts of the board that people are working on, it's going to say, oh, hey, I can't do that. I got a clash here. What do you want me to do? So that's going to happen sometimes at some point in the future. That won't be in 9. That's a rather complex programming exercise. But we have some good ideas on it. We have good people that can work on it, and I'm pretty sure it's going to happen at some point. So I think that's it. I think I'm out of time, aren't I? Yep. Thank you. Thank you for attending. I appreciate it. And I'm out front here. If anybody wants to talk to me, please feel free to stop by. Thanks.